In example 2, we're going to go graph exponential functions using a table of values. If we take a look at our function, we want to graph f of x equals 1/3 to the x. Now before we get started, let's take a look real quick at the box on the previous page. This gives you an idea of exponential growth versus exponential decay. Our exponential growth functions are going to increase from left to right, and our decay functions are going to decrease from left to right. You can take a look at the domain and the range and the similarities between them. The y-intercepts, notice they both have a y-intercept at 0, 1. They do not have an x-intercept, and the asymptotes are at y equals 0. And your asymptotes are always going to be dotted lines. So it's not shown on this graph, but let's draw it in real quick so you understand. This is your asymptote. Your asymptote is the line that the graph is approaching, but it will never touch. Since that asymptote is the x-axis, that's the reason why we do not have an x-intercept. So with that in mind, let's take a look at graphing this function. Now, if we take a look at the function itself, which is f of x equals 1/3 to the x, this number right here, which is called the base of the function, if that number is between 0 and 1, this is going to be a decay function. When this value is greater than 1, that's when you have your growth function. So let's start by filling out our table just like we were doing in the previous example. So I'm going to start and take that 1/3 and raise it to the -2. And if I do that, basically what I'm going to have is 3 to the -2 over 1 to the -2 using my properties of exponents. Oh, I'm sorry, these become positive. Oops. Let's fix that. So this would become 3 to the second after we move it to the top, and 1 to the second when we move that to the bottom. Apologize for that. So 3 to the second is going to be 9, and 1 to the second is just 1. And 9 divided by 1 is just 9. If we then do 1/3 to the -1, remember the raising it to the -1 is just like taking the inverse of it, so that's just going to be equal to 3. So we can say 1/3 to the -1 is 3. Anything raised to the 0 power is always 1, so that's just going to be 1. 1/3 to the first power is just 1/3. And then if we take 1/3 and raise it to the second power, remember that's like taking 1 to the second over 3 to the second, which would be 1 over 9. So here would be 1 over 9. Our asymptote, just like above, is going to be at y equals 0. So there's our asymptote. And I would recommend just graphing that asymptote first so you know where you're at. It should be a dotted line, never solid, because it's not part of our graph. And then if we plot some points, we have the point -2, 9. So that's right there. We have the point -1 and 3. We have the point 0, 1. 1 and then 1/3, that's just an approximation. You're getting really close to that asymptote. Same thing with 2 and 1/9. It's there somewhere, very close. And then we're going to draw in our graph, which our graph is going to curve, and then it's going to kind of ride along that asymptote. It's going to get as close as you can to that asymptote, but it's never going to touch it. What I'd like you to do now is to try this, so you can go ahead and pause it, and then unpause it when you're ready to check your answer. If you did the try this correctly, your table of values should have 1 over 4, 1 over 2, 1, 2, and 4. Your asymptote still is at y equals 0. And then if we graph these points, we have the point 2, 4, 1, 2, 0, 1, and then -1, 1/2, and we just keep getting closer and closer to that asymptote. Remember, it's going to curve up, and then it's going to ride along and get as close to that asymptote as we can. If you have any questions, please let me know.